Okay, now, if you have a device with you and you have not registered it, you may leave 10 minutes early to go down and do that. Understood? You got that, Yusuf? Okay, good. Now, let me catch you up with where we were. This is a different class as opposed to the problem that we started, so I'm going to catch them up with this. Okay. What we're going to do now is Daniel, we're going to heat ice. Solid H2O. We're going to heat it from negative 20 degrees Celsius to positive 100 degrees Celsius. Let me tell you something about the process that you already knew before you even became 10th graders, okay? When you heat ice, it melts, okay? When you heat ice, it gradually absorbs energy, and the kinetic energy of the molecules will increase, correct? Now, when it gets to 0 degrees Celsius, it will stay at 0 degrees Celsius until it turns into liquid water. So it will go from solid H2O at 0 degrees Celsius to liquid H2O at 0 degrees Celsius before it starts to increase its temperature. Is there anybody who is confused about that? Amanda, did you know that before you moved into this class back in September? Yeah, of course you do. Ice melts at 0 degrees Celsius, and it will melt at 0 degrees Celsius until it's all melted. Make sense? Right? If I have a beaker of ice, and it's 0 degrees Celsius, when will it start to increase its temperature? When it's all, Fabiana said it right there, when it's all melted, obvious, okay. Well, why doesn't the temperature change if you're adding heat? Wouldn't the kinetic energy be increasing if you're adding heat? But is the kinetic energy increasing when you add heat to 0 degree Celsius ice? Is it? No, because it's not increasing its temperature. So what's increasing? Something is increasing. True or false? You're adding energy.
True.
Good. So what's increasing?
The energy added.
The kinetic energy is not increasing, so what's increasing? The potential energy is increasing. You're increasing potential energy. And the energy that it absorbs is 80 kilocalories per kilogram. That heat, that potential energy is called the heat of fusion. Heat of fusion. I don't have it written there. It's heat. It's called the heat of fusion. Mustafa, you okay?
Yeah.
Okay. The heat of fusion, HF. Just think nuclear. The heat of fusion. Fusion. The molecules are fused together because it's ice. Think of something to connect fusion with ice melting or ice forming, okay? Right? Then when it hits 0 degrees Celsius liquid, it's going to increase its temperature, correct? It's going to increase its kinetic energy. How do you know? Look at that graph. What evidence do you have that that liquid water, Joseph, is increasing its kinetic energy? What's the obvious evidence?
Temperature is increasing.
The temperature is increasing. Thank you, Joseph. We have Joseph, he's split in two separate personalities. We have Joseph that speaks English as a first language, and we have Joseph over here that speaks Spanish as a first language. Excellent, Joseph. I like that. Very good. And that was the Spanish half of Joseph that actually answered that question. God bless all Hispanic speakers. I love it. Excellent. You're welcome. Excellent. Now, so the reason you know the kinetic energy is increasing is because the temperature is increasing. Excellent. So, when is the temperature going to stop increasing, yet the heat will continue to be absorbed? Look at the drawing behind me.
120.
When it's at 100 degrees, when it's going to start boiling, right? Isn't it? It's going to start boiling there at 100 degrees. Shall I make a line over there? At 100 degrees, it'll start to boil, and it will stay at 100 degrees until it's all gas, correct?
And then it will evaporate.
And then it'll start to, it's all going to evaporate or turn to steam. We call it steam, okay? and then it'll start to increase its temperature. How do you know it's increasing its kinetic energy? Because the temperature is increasing. Clear? So there are actually 5 parts to, that's fine. There are actually 5 parts to this problem. Yes? 5 distinct parts. There's the heat it takes to go from negative 20 degrees Celsius to 0 degrees Celsius, correct? There's the heat it takes to go from 0 degree ice to 0 degree water. Then there's the heat it takes to go from 0 degree water to 100 degree water. Then there's the heat it takes to go from 100 degree water to 100 degree gas. Then there's the heat that goes from 100 degree gas to 120 degree gas. There's 5 heats. Clear? Yes? Okay, now, these are the heats here. So it's the mass times the change in temperature times the specific heat capacity. Specific heat capacity is, listen carefully. You ready? The amount of heat needed to raise 1 kilogram of substance 1 degree Celsius. The amount of heat needed, here it is here, here's the specific heat capacity here. Kilocalories, the amount of kilocalories needed to raise 1 kilogram of water 1 degree Celsius. So, if the specific heat capacity of water is 1, how much heat would it take to raise 2 kilograms of water 1 degree? 2 kilocalories, right? Makes sense? So you multiply the mass times the change in temperature times the specific heat capacity, correct? Does that make sense? Okay. The heat of fusion is just, there's no change in temperature, is there? So it's just the mass times the heat of fusion. Then there's the liquid water is the mass times the change in temperature times the specific heat capacity of liquid is the one we were just talking about, 1. And then the heat of fusion, the heat of vaporization times mass, and then the steam. Clear? So what we're going to do is we're going to find out, we're going to take what I said on the first half of this, we're going to do 1 kilogram. 1 kilogram. Everything that you need is on the board. There's nothing else you need. If I ever gave you a problem like this, what you need is the heat of vaporization. You need the heat of fusion. You need the specific heat capacity of solid water. You need the specific heat capacity of liquid water. You need the specific heat capacity of gaseous water. Those are the 5 things you need to do this, yes? You need to know how much you're starting with. You need what mass you're starting with. You need to know the starting temperature. You need to know the ending temperature. Clear? Shall I just write this on the board? You know what I'll do? I'm going to stop the video. I'm going to make a part 3. I'm going to stop it, write it on the board. We'll do it together. I'll put on the video and it'll be there for posterity. Clear? We're off.